Hello everyone, this is Luna. In today's lesson, we will use Blender to create procedural veins and easily produce growth animations. In many biological research paper figures, cells and blood veins are very common elements, but manually creating these models is highly inefficient. Today's method allows for the generation of many random and different forms with a single click. Next, let's proceed with a practical demonstration. First, hide the completed veins object I made earlier and take a look at the cells in the scene. In this collection, there are cells stacked together, each being identical small spheres with a displace modifier applied. The basic principle is to first convert these spheres into one large sphere, then select some start points on this sphere through index value. And use an empty object to find the point with the shortest distance on the sphere as the end point. Blender can automatically generate curves from the start points to the end point along the surface of the object, which can then be converted into models. Create a cube and scale it down, then apply the scale. Open the Geometry Nodes panel and create a geometry node. Hold Shift+A to add nodes, or use my shortcut Shift+Z. First, drag the cells collection into the geometry nodes and hide the original cells. Use Mesh to Volume to convert the models into a volume, increasing the density. Next, use Volume to Mesh to convert it back into a solid model. We notice that the small spheres haven't merged together because each sphere is currently an instance. We can use Realize instances to convert them into actual geometry, allowing the spheres to merge. Then, use Triangulate to convert all faces into triangles. Next, create a shortest path node, which can be used to specify the end point. Create a sample nearest node and connect big sphere to geometry. Move the cube to Scene Collection. Drag an empty object from the scene into it. Connect empty location to sample position. We can read the index of the point on the large sphere closest to this empty object. Then, use the index and a compare node to select the nearest point as the endpoint. Create an Edge Path to Curve node, which automatically generates many curves. To reduce the number of curves, we need to set some start points. Similarly, we can assign a random value to each index. If this random value is greater than 0.8, these points can be used as start points. However, the default curves don't look smooth. We can use Set Spline type to smooth them. Then, use Curve to Mesh and a Circle node to convert the curves into models. But each curve is the same radius, which isn't realistic. We need each curve to gradually taper. Create a spline parameter node and connect the factor to the scale, which will produce veins like models. Next, add a trim curve node to set the growth animation. Adjusting the start value will achieve a growth effect from nothing to full length. Finally, add a set material node to assign a material. Switch to the rendering view, and you'll notice the color looks a bit off. This is because the veins overlap partially, and subsurface scattering materials can't be used. Switching to another material will fix this. Switch to the material panel, and let's take a look at the cell material. The setup is very simple. The color is blue, and noise is connected to the normal to add surface details. Set the subsurface scattering value to 1 and transmission to 0.5. Finally, use layer weight to create edge glow. The blood vessel material is even simpler, just a red color, with noise added to create surface bumps and details, and subsurface scattering enabled. For lighting, use a key light from the top right and a fill light from the left. Find a suitable angle, click render, and you'll get the final image. These are the steps for creating procedural blood vessels in Blender. If you have any questions, please leave a comment, and I'll reply promptly. The demo file is also available in the link in the comments. Feel free to download it if needed. Thank you for watching, and see you in the next video.